would you bet your life or your career that the configuration of every network device in your organization is doing exactly what it's supposed to do? Never once did I have a single hand raised. Never once. I want you to think about the reality that represents. What it means is we actually don't know what's happening. Like, we do our best. Like, nobody ever goes in and, well, at least most people don't go in and intentionally misconfigure devices. But what they realize is the complexity is so great. The interaction of multiple devices is so great. The potential for one little change to either be done incorrectly or to be done in a way that is forgotten. It was done for a particular purpose. Let me give you a couple of examples. I was at a very large retailer, household name. You would know them. You've probably shopped there. Can almost guarantee that you have. I was at their headquarters facility. I was with their security team. And their story to me was, we do not allow any inbound internet traffic at all. So everything has to be initiated from inside the company. No outbound traffic can get in. We ran our analytics and there was one access from the outside into the network. Now, this was not supposed to be possible. This was against policy. This was against everything that they understood. I took one look at it. I looked at the source IP. I looked at where it was going within the organization. I called over the security team and I pointed at it and I said, I can tell you exactly what's happening here. Somebody who's responsible for managing your infrastructure needed to get access from home. They poked a hole through the firewall so they could get an access in from home. They could do some work that they had to do. And then they forgot that it was there because this has been there for 8 months. This is a real example. Nobody knew about it. There was no comment in the configuration. It was just tossed in to open this port. This is a real example of what complexity does. And I have examples that go all the way to another example of an organization that was breached and very publicly. The access into their network was so pervasive that when we drew a map of it, it was impossible to see because it saturated the map. But they didn't know it because, again, complexity is the enemy. We found access to a very critical part of Cisco's network. It was access to their certificate database that they used for their VoIP systems. And they had misconfigured a single firewall. And as a result, it was possible to access that certificate server and steal certificates. Now, that never happened. Let me be really clear about that. But the access was there. So if Cisco can't get it right, how can anybody? This is something I really want you to kind of spend some time thinking about, the impact of complexity, especially if you're not doing some kind of analysis of how things are really configured. Let me revisit zero trust here for a second. I picked the NCSC elements simply because they're easier to outline. If we look at what the NCSC says about zero trust, they say, look, you need a single strong source of user identity, user authentication, machine authentication, so the devices have to authenticate as well, additional context, authorization policies to access an application, access control policies within an application. That's really hard to do. It takes a lot of money. It takes a lot of administration. It takes a ton of effort. Build an environment that allows you to be much, much safer and to narrow the attack surface, to make it as narrow as possible so that you can focus in on that narrow attack surface. It's easy to blame users. It's easy to say, oh, that user clicked on that URL. It's their fault we have ransomware. No, it's not. They're going to click on the URLs. Stop believing that you can do anything to get them to stop. Instead, make it so that if they do, it doesn't hurt anything. Focus on the data. What is the data you're trying to protect? Focus there. Limit the attack surface. Limit the ability to get to that data. Narrow it down so much that this rudimentary garbage that's trying to lock you out can't do it. The way the ransomware works is it encrypts locally and it uses like fetch, upload, delete, whatever for network shares. It uses the sync stuff. It encrypts locally. It's going to talk to cloud. Obviously, local file encryption, you can just encrypt that stuff. But the attack activity takes place on the user device. The enterprise data is stored somewhere else. That data should never, ever be reachable natively as a native file by a user device. So ask yourself these questions. How can a user device access the data? When they access it, what can they do to it? And what's the process for manipulating data? Because remember, what ransomware in this case is trying to do is they want to encrypt the data so you can't read it anymore. If you look at this application, it is not possible for the user device to change the data. It has to go through these middle tiers. It has to go through the presentation tier, it has to go through the logic tier, and it has to go through the data tier. And each of these are limited in how they can be accessed. So as an example, the database can only be manipulated by trusted servers at certain IP addresses, which have different protections than an end user device would have. For instance, they don't have browsers and they can't get to the internet. That has critical data from having these tiers such that you have authentication and authorization at multiple points. You're authenticating machines, you're authenticating users. The end user device has no access to the data to do anything to it. They can manipulate the data using these middle tiers, but we've now eliminated the potential for ransomware. Like the current ransomware model will not function against this kind of data. The defense gets straightforward. And I think we've just been focusing wrong. I think our focus latched onto because of the early days of viruses and the way that they functioned. And we got to the point where we felt like that needs to be what we protect, but that's not really what we care about. Ideally, at initial compromise, as those early stages start to do their thing and they start to settle in, and that staging part of the process is happening, it is possible to see that behavior and to address it at that point. But here's the bottom line, you guys. You can't buy your way to security. You actually have to do the thinking, do the design, and focus on what you're protecting. So what are you protecting? What's the attack surface for the thing you're protecting? What are the attack vectors that can get to it? And who are the actors from which you're trying to protect the data? Because ultimately, let's be clear, if there's a user that has native access to data, that user will be able to do something really bad. I'm not saying that no one should have that access, but you should be really aware of what it is. You should know what your checks and balances are and so on. And nobody else should have native access to the data.